This question asks us to find what the value of X and Y are in the table and to give a reason for the choice of methyl orange as an indicator. We are given the reaction equation. We can see we have an acid. Specifically, hydrochloric acid is a strong acid, which means it dissociates fully in solution. And we are told potassium carbonate is a weak base. We saw in the previous video that weak bases dissociate only partially in solution. Now this weak base is a metal carbonate. When an acid and a metal carbonate react, a salt, in this case potassium chloride, water and carbon dioxide are produced. This is a type of neutralization reaction, and we are told a titration experiment is performed with the acid and base. 25 centimeters cubed of the acid are used, and this would have been pipetted into the conical flask. We are also given its concentration. The burette would have had the potassium carbonate solution in it, and we don't know its concentration. We are given a table showing the readings on the burette in 2 trials or runs, which are repetitions of the titration. We need to start by calculating X. In trial 1, the initial reading is 6.5 centimeters cubed, which is read off the bottom of the meniscus. We do not know the final reading, but we are given the volume of the potassium carbonate solution used or transferred from the burette into the acid in the flask. The volume transferred from the burette is called the titer. The titer is 20.05 centimeters cubed. So how do we work out X? The titer volume is equal to the difference in the 2 readings, namely the final reading minus the initial reading. So if we rearrange this formula, we get final reading is equal to titer minus initial reading. Putting in the values, we get 26.55 centimeters cubed for X. Then we are asked for the value of Y. Again, the titer or volume transferred is the difference in the final and initial readings. So the initial reading is the final reading minus the titer. The initial reading is Y. The final reading is 48.3 centimeters cubed. And the titer is 20.15 centimeters cubed. Putting in the values and solving, we get 28.15 centimeters cubed. We are then asked why methyl orange is chosen as an indicator. First, we need to know what equivalence point is. It is the point in a titration at which all the acid and base are used up. An indicator changes color just after equivalence point, at the end point, and the color change tells us the reaction is over. Different indicators change color in different pH ranges. We need to figure out the pH range in which methyl orange changes color. A strong base and a strong acid react to produce a neutral solution with pH about 7 at equivalence point. A strong acid and a weak base at equivalence point produce a slightly acidic solution. A weak acid and a strong base produce a slightly basic solution, and a weak acid and a weak base produce a neutral solution. In the given reaction, we have a strong acid and a weak base reacting, so the final solution at equivalence point will be slightly acidic. So methyl orange must change color in the slightly acidic region.